I am the manager of securityfriday.com. Today, I will explain the method of the promiscuous node detection, which uses the ARP packet. As a hacker, when we try out new tools, we should always read the readme.txt file. It is because readme file always contains important information about the function of the tools. Here is a readme file of my speech. As you can see, I am not an English native speaker. So when you are listening to my speech, you may come to this situation. So my advice is, please change your ears to the promiscuous mode so you can get all the information in this speech. Agenda. This is an agenda of my speech. To understand the mechanism of the promiscuous detection, I will begin with explaining some basic technologies. The first one is the hardware filter, which is done by the NIC. Next, I will explain address resolution protocol. This protocol is what we are going to use to detect promiscuous. And third, I will explain filtering with software. Here we will discuss what kind of filtering which is done by the kernel. Promiscuous is detected by using these three basic technologies. And at the end, I will explain the exception that I know. Hardware filter. Everybody knows that our PC usually does not receive all packets on the network. It only filters and takes desired packets. When a packet reaches the PC by passing the NIC, it is filtered in the NIC. We will call this filter a hardware filter. What this filter does is to check the hardware address of the packet. Notice that we are talking about the hardware address, but not the IP address. Here are some hardware filters: unicast, broadcast, multicast, all multicast, and promiscuous. Unicast. This is a general filter. NIC has a unique hardware address in 6 bytes. Only the packet to the hardware address of the device can pass. For example, if the hardware address of the device is 001122334455, and if there is a packet with address 001122334455 is being sent on the network. In this case, since the address of this packet and the hardware address of the device are the same, therefore the packet can pass the hardware filter. On the other hand, if this is a packet with address 001122334401 being sent on the network, the address of this packet is not the same as the hardware address of the NIC. The packet is rejected by the hardware filter. Broadcast. This filter passes the broadcast packet. The hardware broadcast address is FFFFFF FF. When you send the broadcast packet on the network, the packet will pass the hardware filter. The ARP request packet usually uses this hardware broadcast address, and we will discuss it later. Multicast. In this filter, only the multicast address registered in the multicast list can pass the NIC. For example, multicast address 1 and 3 are registered in the list. Ethernet multicast address 1 is 010058000001. Ethernet multicast address 3 is 0100580003. When the packet with multicast address 1 is sent on the network, the multicast packet passes the filter. It is because multicast address 1 is registered in the multicast list. Next, when the packet with multicast address 2 is sent on the network, the packet will be rejected by the hardware filter. It is because multicast address 2 is not registered in the multicast list. All multicast. This filter simply passes all the multicast packets, so it does not check the multicast list. Then how does the hardware filter define multicast packet? In the hardware filter, the packet where the group bit is set is a multicast packet. Therefore, the all multicast filter passes all the packets in which the group bit is set. The group bit is LSB of the first byte of the hardware address. Please look at this figure. When a hardware address is 01, 02, 03, 04, 05, 06, the first byte is 01. When you show it by binary, it is 000000000001. The bit on the right edge is a group bit. This is very important. When the all multicast filter is set, the packet is with the group bit is set can pass the filter. Notice that this filter tests only the group bit. For example, if there is a packet with address 010000000001 and is sent on the network, the packet can still pass the hardware filter because the group bit is on. However, if the packet of address 020000000001 is sent, the packet will be rejected because the group bit is off. This is all I want to say about all multicast now. Promiscuous. Next is the promiscuous mode. When the NIC is promiscuous, all packets can pass the filter. Sniffers set the NIC to this promiscuous mode in order to receive all packets. So all packets in the cable are received. When the NIC is promiscuous mode, the hardware filter does not test the hardware address of the packet. All packets can pass the NIC. And now, we want to detect all NICs which are set this mode. Default hardware filter. Now I will explain the default hardware filter that PCs are normally using. This is a default hardware filter of both Windows and Linux. Unicast. Of course, packets with the host hardware address are passed. Broadcast. By default, all broadcast packets are received. This is required to the address resolution such as ARP. Multicast. Multicast address 1 is passive. Multicast address 1 is an address which all hosts should receive. This basic operation is important for promiscuous detection. Next, we will discuss the use of our packet which can detect promiscuous. ARP. ARP is Address Resolution Protocol. It is explained in RFC 826. It is a protocol used to search for the hardware address corresponding to an IP address. Everybody knows ARP well. IP address is not a hardware address. The application cannot send a packet if it knows only the IP address. It has to search for the hardware address corresponding to that IP address. This task is done by the ARP packet. This is a basic flow of ARP. I will not explain the ARP table today, but only the ARP packet. To send the packet to an IP address, it first needs to compose an ARP packet in which contains the requested IP address. The ARP packet then is sent to the broadcast address. All nodes in the local net will receive that ARP packet. Then the node with the request IP address will reply along with its own hardware address. Thus, the hardware address is resolved from the IP address in the local net. This is a format of the ARP request packet. The format of the ARP reply packet is similar to this. The first 3 lines are headers of Ethernet. The first line is destination address of the Ethernet packet. This part will be filtered by the NIC. In a normal usage of ARP, it is broadcasted to FF, 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 FF. The last line is the request IP address. IP address of the target is set here. Test 1. When the ARP packet requesting a hardware address is sent to the broadcast address, the requested node receives the packet. Since it is broadcast address, the packet passes the hardware filter, and the node responds by sending the ARP reply packet. This is a flow of basic ARP. Here is our idea of the promiscuous detection. When we do not set the broadcast address, for example, we set the destination address to be 000000000001. If the NIC is in normal mode, the ARP packet is rejected by NIC. However, if the NIC is in promiscuous mode, the packet passes the NIC. If the request IP address is corresponding to the IP address of the node, the node responds to the ARP packet. This is what I thought. However, the node does not respond. So the promiscuous node cannot be detected by this method. Consideration of test 1. Why is there no reply? When the NIC is in promiscuous mode, the ARP request packet surely passes the NIC. The request IP address is also correct. I expected the reply, but there was no reply. So I think there must be some kind of filter in the software. We call it a software filter. What kind of filter is it? Is it a multicast filter? Is it a broadcast filter? Let's look at the Linux kernel source code. This is a part of the source code of the ARP module in Linux. There are the filter of the ARP. In red. Here, if loopback TIP or multicast TIP, then go to out. This checks the request IP address. If the request IP address is loopback address, go to out. And if the request IP address is a multicast address like 224.star.star.star, then go to out. This is not a filter in the hardware address. This is a summary of the filter in the ARP module. First, it checks the following conditions. If ARP message is correct, if a packet is not other host, if a packet is not loopback, if the request IP address is not loopback, if the request IP address is not multicast, then the ARP module will respond to the packet of throughout the broadcast and multicast. This is how the Linux kernel implements ARP. Classification of packet. Then in the software, what is a 2S packet? What is a multicast packet? What is a broadcast packet? Since I want to check the classification of the packet, I will check the classification of the Ethernet packet. This is a part of the source code of the Ethernet module in Linux. The first bit of each disk is tested by the first if line. Each disk is a 6-byte hardware destination address. In this line, LSB of the prime byte is tested. This is the group bit is tested. When the group bit is set, the kernel checks whether each disk is a broadcast address. If it is a broadcast address, the packet is packet broadcast. Otherwise, the packet is packet multicast. Next, if the group bit is not set, device address of NIC and HDist are compared. If they are not the same, then it must be packet for other host. This is a flow chart of the classification of the packet. There are 4 kinds of packet used to detect promiscuous. There are other host to us, multicast, and broadcast. Please recall the ARP module. When the ARP message is correct, ARP will execute its software filter code if hardware destination address is any of to us, multicast, or broadcast. In a case that certain packet is received, first, the group bit of the packet is tested. If it is true, the hardware destination address are compared to the broadcast address. Of course, the broadcast address is FF. If it is yes, the packet is broadcast. If it is no, the packet is multicast. In both cases, the ARP module will respond. Next, in the case that the group bit is not set, the hardware destination address are compared with the device address of the NIC. If they are equal, the packet is a to us packet. And the ARP module will respond to the packet. If the hardware destination address is not equal to the device address, packet or other hosts, the ARP module will not respond to this packet. In the case with Linux, the promiscuous node might be able to be detected by using ARP packets. The packet type, the hardware filter, the software filter, and the NIC mode were shown in this table. The to-us packet passes the hardware filter and the software filter in the normal mode and in promiscuous mode. So this packet cannot be used for promiscuous detection. The following line is other host packet. When NIC is a normal mode, this packet is rejected by the hardware filter. When NIC is a promiscuous mode, this packet passes the hardware filter. However, it is rejected by the software filter. Either mode does not have to response. Therefore, these cannot be used for promiscuous detection. Next, we look at the broadcast packet. Either mode also has to respond to the broadcast packet. It cannot be used for the promiscuous detection because there is no difference in the result. The multicast packet was classified into 2 types. One is an address registered in the multicast list. Another one is an address not registered in the multicast list. The packet having an address registered in the list passes the hardware filter. The packet also passes the hardware filter in the promiscuous mode. Because the ARP module responds to the multicast packet, either mode had respond the packet. this packet cannot be used for the promiscuous detection. Next is a multicast packet not registered in the list. When the NIC is in normal mode, this packet is rejected by the hardware filter of the NIC, so there is no response at all. However, when the NIC is in promiscuous mode, this packet passes the hardware filter, and the following software filter does not reject this packet either. Then the ARP responds to that packet. Here, the result of the normal mode and the promiscuous mode are different. Promiscuous can be detected with the ARP packet, which sets the multicast address not registered in the list. Next, we try sending a packet where the group bit is set. Neither the multicast nor the broadcast are included in this packet. When the NIC is in normal mode, this packet is rejected by the hardware filter of the NIC. When the NIC is in promiscuous mode, this packet passes the hardware filter. The following filter does not reject this packet either. Then the ARP reply returns. At this group bit packet, the result of the normal mode and the promiscuous mode are different, so it can detect promiscuous. To highlight our results, this pink zone can be used to detect promiscuous for Linux. Next is Windows. However, I'm sorry, I don't know the software filter of Windows because I have not seen the source code. However, there must be some kind of software filter. So in order to understand how it works, I performed some tests. Here is how I test the filters. I used 7 kinds of special hardware address to test the software filter. The first address is a broadcast. This is a usual ARP packet. Therefore, it is expected that all nodes respond. ARP might not run if there is no response in it. The second address is fake broadcast with only 31 bits. It is broadcast in which only the last 1 bit is dropped. Since that 1 bit is dropped, this packet is actually not a broadcast address. If the software filter does not completely compare 6 bytes, this packet might be classified into the broadcast. The third address is fake broadcast with 16 bits. It is the same as the broadcast address, but only the first 16 bits of the head are set. So this packet is also actually not a broadcast. If the software filter compared only 1 word, this packet might be classified into the broadcast. The fourth address is another fake broadcast with 8 bits. Here, only 1 byte of the head is the same as the broadcast. If the software filter compared only 1 byte, this packet might be classified into the broadcast. The fifth is multicast address 0. In general, multicast address 0 is not used. It is an address not registered in the multicast list. The hardware filter is supposed to reject this packet. However, the software filter might classify the packet as a multicast packet. The sixth address is multicast address 1. This packet passes the hardware filter by default. It is to test whether the software filter passes a multicast. The OS does not respond to the multicast of all the addresses if there is no response in this packet. Finally, it is an address where the group bit was set. This packet might be classified into the multicast as in Linux. This is a result of test 2. When the NIC of Windows 95 and 98 and ME were in normal mode, 7 kinds of hardware addresses are tested. There was a reply in the broadcast and the multicast address 1. The result is the same as we expected. Next, the mode of NIC is switched to Promiscuous. I was surprised. In the Promiscuous mode, there is a response for the fake broadcast request. As a result, the Windows 9X series might classify the broadcast by just checking 1 byte on the head. Anyway, as a result, the Promiscuous node of the Windows 9X series can be detected by using the ARP packet. When the NIC of Windows 2000 is in normal mode, the result is the same as we expected. There is a response for broadcast and multicast address 1. Next, the mode of the NIC is switched to Promiscuous. The result is there is a response for 31 bits and 16 bits fake broadcast. It is no reply for 8-bit fake broadcast. Windows 2000 might classify the broadcast by 1 word. And the Promiscuous node of Windows 2000 can be detected by using the ARP packet. In our test, the result of Windows NT4 is the same as the case of Windows 2000. The final is Linux. I have already explained the result of Linux. When NIC of Linux is in Promiscuous mode, I expected that there was a response in all the addresses where the group bit had been set. The group bit in 7 kinds of address used for this test is set. There is a response in broadcast and multicast address 1 in the normal mode. The mode of NIC is switched to Promiscuous. The result is the same as we expected. There is a response for all packets. The Promiscuous node can be detected also for Linux by using the ARP packet. Exception 1. Thus, the Promiscuous node of Windows and Linux can be detected by using the ARP packet. However, there are some exceptions. The first problem is old NIC. Some NIC does not support the multicast list. For example, it is Etherlink 3. It is a NIC which does not support the multicast list by default in all multicast mode. In a word, all packets where the group bit is set are passed. When these NIC are in normal mode, the result becomes the same response as Promiscuous. Let's buy new NIC if there are some old NIC in your local net. Exception 2. When 3COM3C905 is used with Linux, the default is all multicast. The installer of Linux automatically set its driver to 3C59X.0, which is an older driver. This driver seems not to support the multicast list. Consequently, the NIC becomes all multicast by default. When the newer 3C905X.0 is used, then there is no such problem. Exception 3. This is a useful exception. The response by the normal mode changes if Windows 2000 dynamically loaded capture driver is installed. It responds to a fake broadcast with 16 bits. The user who installed WinPCAP 2.1 and SMS system management server can be detected. It can be detected that they have been installed even if they are not started. And it responds to a fake broadcast as 31 bits when the sniffer runs. Okay, demonstration. Let me give a demonstration. Wait a moment. Now, 3 PCs are connected to a local network. This one is my Windows 2000. I will run Promiscuous on this machine. Promiscuous is a promiscuous detection software I wrote. Over there are the Malicious Windows 2000 and Red Hat 7 machines. Then I am going to scan the local network using Promiscuous. Now start. Here we can see that 2 nodes are found, but none of them is in the promiscuous mode. Next, let me change the malicious Red Hat machine to the promiscuous mode. It is in promiscuous mode now. Then let me scan the network again. It appears that malicious Red Hat responds the fake broadcast packet. Now, let's look at what will happen to the Windows 2000. We will run a sniffer here. Now start it. Then we scan again. We can see that malicious Windows respond to fake broadcast 16 and 31. So this software detects the promiscuous node. Test tool. You can download the test tool from our site, Promiscuous, www.securityfriday.com. And please report your test result to us. The end of presentation. Is there any questions?
1 second. 1 second. We need to translate them.
Wait a
We
moment.
translate the questions and answers. So.
Please.
Have you tried this on 3DSD?
3DSD はやったことあります。
少しのマシンをいくつかのマシンを試しましたが、結果は Linux とほとんど同じです。
Sorry.
Test.
He tried a few machines, but the result is almost same as Linux.
Is there any question?
You really want to break down the house. Have you tried this on the wireless network that's currently happening in Blackout?
今これワイヤレスのネットワークでやったら全部落ちてるんですね。ワイヤレスランのネットワークがあるからですね。
ワイヤレスネットワーク。
困りますね。Of course.
Since it looks like Microsoft and Linux seems to be sort of a bug, but a useful bug, would you tell Microsoft to fix this bug or to leave it in so that you can detect when systems go promiscuous?
このバグはあった方が世の中のためなんじゃないかと思います。
He thinks it is useful for everybody.
Sorry.
Can you speak up, please?
Ah, その意味は、IP アドレスを割り当ててないマシンという意味ですか。
It is same as IP address. IP address was not assigned, or you just don't know.
このツールは、セグメント全体をスキャンするんで、そのセグメント内のアドレスであれば見つけることができます。
This tool scans one segment, so if the machine in the one segment, so it will find it.
Have you tried broadcasting to the IP address of 127.0.0.1?
Can you repeat again?
Have you tried broadcasting using an IP address of localhost? And has it made any, if so, has it made any impact on your results? Now, if you do this to Solaris 251, the thing goes nuts. It blows up in interesting ways. So I'm curious if you tested it.
ローカルホストが1270001に対してスキャンした場合にどうなるかなんですか。
え
今全然平気だ。
ーあまずソラリスではこの手法が全然通用しません。私たちのテストでは。
First, this test doesn't work on Solaris.
そして、記憶が定かではないですけれども、その手のアドレスは全部テストしました。
He was not sure, but he tried to test like this a local host or a special address. He tested all of them.
そしてレスポンスはありません。
And no response.
Second line.
That's okay.
Okay.
確認だけでして。
あ、確認だけ。こちらだけ。はい。
Two questions. Is the source code to Promiscuous available and has this been tried against hardware sniffers like the original?
ソースコードが。Could you speak again?
Is the source code to Promiscuous available and has this been tried against hardware sniffers like Network General?
ネットワークジェネラルのハードウェアスニファーに対して試したことはありますか。
ハードウェアスニファーには有効ではありません。
It is not valid for hardware sniffer.
あ、ディストゥールは、なんていうかな、テスト的に作っていってるんで、現在はまだソースコードを公開していません。
Now he is still development and testing, so the source code is not available right now. まだ。
まだ。
How well does this work on a machine that's promiscuously sniffing but doesn't have enough IP stack? Like an IES machine that uses your packet driver. You detect all of those using this.
マイク入ってない。マイクが入ってない。あ、そっちじゃない。あれ？
One more time.
Okay, if you have a machine that's sniffing, okay, that doesn't have an IP stack loaded, but it's an IES intrusion detection system that has a raw packet driver, okay, so it will be sniffing, but there's no IP stack loaded. Will this software be able to detect that? If so,
だけど IP スタックがない場合にそれを検出することができます。
あ、それはできません。
This tool cannot.
Is there any question? No? Please.
why Security Friday, not Security Saturday?
Oh, okay. Good question. 日本で説明しようかな。日本で一番有名なスキャンダル写真週刊誌はフォーカスという名前です。
はい。sorry. So in Japan, the number one scandal magazine is called Focus.
then we call Friday,
That's why we call it Friday,
not security focus.
not security focus.
sorry、ちょっと説明が足りないですね。2つあって、1つがフォーカスで、もう1つがフライデーなんです。2つあるんですね。すみません。
There was a mistake. So the two famous scandal magazine in Japan is one is called Focus, and second one, actually I'm not sure which is more popular. Focus and Friday. So that's why he called Security Friday.
Is there any question? こちら。Please.
Ethernet that one-way connecting.
TX line? It means. イーサネットのケーブルを切ってしまったら、
What is to happen if you cut off the Ethernet line? The TX?
TX ライン。もちろん素晴らしいハッカーは TX ラインを切ってスニフィングするでしょう。
So the great hacker will cut the TX line and sniffing.
Well, thank you very much. Thank you very much.